Hello, this time I want to show you some details about the graphics in this game Pfahrer, Panzerfahrer. So, as you see, you have the tanks, they can rotate, they can drive, they have these, when they drive, they dig up the dirt, and they also do some sound, but today I want to talk more about the graphic stuff. You see these explosions and the smoke, and yes, I want to show you how I made it. So this is the folder. You have this index.html where you have the HTML. You have some style information where the game field is, and you have 3 JavaScript files loaded, and you have some connective code that starts that manages the sound, because the sound is handled by the HTML, and then all other things are handled to handed over to the game script. Yes, you also have then here the description and so on. Yes. The sound folder just contains all the files that are played when some shot happens or when an explosion is there. In this JS folder we have our scripts, and I now open them all with gedit. And on the graphics side I have the textures, and I want to explain how I did these textures. At first, the landscape. You see, the landscape is very diverse. It never looks boring, even though it's very simple. And how I made this, I used a big map which darkens or enlightens the background, and I have a normal map which creates these shadows of the rocks, and you can see this map texture. This shows how this shows where the rocks are in the big map, and this normal map creates the shadows of the sand. And what I did is I calculated from this normal map the lights, I multiplied it with a color value, and I then also multiplied it with the map, but the normal map is more fine-grained than this big map. So the map is the big map, and this is the detail map. Yes. Let's look at the code. I have a shader for this fragment shader sand, and this is the fragment shader sand, and I have the texture of the normal map, I have the texture of the big map, I have the texture coordinates of the normal map and the big map, and I calculate, yes, I fetch the black-white value from the big map, I fetch the normal from the normal map and add minus 0.5 to it, so I get a real normal, and I normalize it with added high map, so I also consider the high map into the calculation. This means that on hills the rocks are more bumpier than on the more enlightened places, and then I calculate the light factor by this dot product, and then I also calculate the color. I also multiply it with the color. Here, this is the color of the whole thing, and then I set the fragment color. So this is basically the landscape shader. And next, the font is very easy. I just have this font texture with all letters, and they are arranged according to the ASCII set, to the ANSI. The explosion is also very simple. These are the keyframes of the explosion, and I do additive. Yes, I do additive graphics. The bullet is just this picture, and for the tank I have 3 parts. I have the shadow of the track, which is drawn more than once. I have the corpus of the tank, and I have the cannon, and if you overlap them both, they are a tank. And also notice that this exactly is the middle point, and so when I rotate one of these both parts, the tank is rotated correctly. Yes, to the shaders, I have a simple fragment shader that just fetches the texture and multiplies it with the color. And the interesting thing is the vertex shader. This shader gets the sine and the cosine of the rotation of a sprite, and also the scale of the sprite, and the index of the sprite inside this map. So I have these sprites. These are 1, 2, 3, 4 in width, and 1, 2, 3, 4, 5 sprites in height. And so this sprite UV coordinates are calculated from knowing how much sprites are on this texture and which sprite actually do I want to get. So there's a lot of calculation in the vertex shader. Yes. This is the texture loading code, and what shall I say? This is the code that loads all the shaders. I have just one vertex array, which just is a rectangle, and I have this yes, I put this rectangle. I load this rectangle once into as a vertex buffer, and then I only change the GL uniforms. Now this function right calls the shader functions. So this function writes a text s to the position x and y. X and y, yes, I set up the correct texture, I set up the correct shader program, and I for each letter in this for loop I set the correct position and calculate it from x plus something that has to do with the position of the single character in the string, and I set the location of the sprite selector to the actual character I'm choosing, and then I call GL draw arrays. This draw function draws a single sprite on a position x, y, and this function this draw just draws a normal rectangle. This function draws a sprite, so I can tell him x, y, w, h, the position where to draw the sprite, the angle, the alpha value, whether it is shadowed, and ABCD are the selector of for sprites. So when I want to draw an explosion particle, which sprite do I actually choose? This draw send function draws the background. And now the main draw function, the main draw call, is in another file. So this drawing.js provides a lot of functions. Add next the particle engine, which also has to do with the game, with the graphics. I have this constructor particle engine, and I have a list of particles, and I have a function push particle, where I can add a particle with x, y, the rotation and the type, and this just adds the information to the array. I have this function draw, which draws all sprites of the explosion parts, and you should remember that I only use one texture for all particles because they are all in this sprite map. And I have this function tick, which simulates the particles. So for an explosion, it increases the frame number, and for for something else, it just destroys the particle. So for a smoke, so actually type 19 is a muzzle flash. So this particle dies after a while. This particle 18 is the smoke, and this decreases the y value, so and adds some random movement to the x coordinate. So the smoke goes up to the sky, and otherwise I have these explosion frames. So the type is changed, is increased, so that it plays through all the frames. I have also this alpha value, which decreases, so the particles are fading out, and this also determines the lifetime. So if the alpha value is smaller than 0, this particle is deleted. Okay, and last but not least, the game engine logic. This function init game creates a new game with 15 tanks and the sounds that are initialized by the HTML. This is the constructor of the game. So this creates a list of tanks, a particle engine, and a list of shots. And in this tick function, all tanks at first all shots are simulated, then the tanks are simulated with this tick function, and then the particle engine is called with the tick function, and then I simulate all the AI steps, the AI simulation. Last but not least, the player sounds are spawned for the tracks. This shot function returns which tank is hidden by this shot, and if a tank is hidden, we do some damage, and finally we add some score if the tank is destroyed, and we when this damage when the tank has enough damage, it starts to smoke, and we also spawn this explosion particle. In the tank simulation, the tank tick returns the shots that the tank creates, and yes, we also spawn sounds for the visible player. In the AI, we have this KI function in every tank. In the draw function, we have at first the background. We bind the sand and so the detail normal map and the big map, and then call the draw function. So we have this background shifted by the player X. Then we disable blending. We bind the textures at first of the tracks of the chassis and then of the turret, and we call all these draw functions. We also draw the progress bar, so the life, the health bar, and we draw all the bullets. And last but not least, we draw the particles, and after that we draw the font, the text over it. So there's not much text, so it's hard coded here. Yes, we have some helping functions. These are the functions for handling the keys to control the tracks of the player. This is the class for the tank. This tank has an X value, a Y value, an angle, also the angle for the turret, the health points, score, and the controls of the tracks. In the draw function, we have different layers, and the layer 0 is the track layer. This is the layer 1, the shadow of the chassis and the chassis. The shadow is shifted right downwards about 4 pixels and has a alpha value of 0.6, and after drawing the shadow, we draw the sprite with alpha 1. Yes, the other layers are the turret and some other things. The health bar. In the tick function, we add a new track to the track list. We also have the simulation of the movement of the tank just by adding something to the position that is based on the angle and the track motors. Now we have the shots. We have helper functions, distance and collide width. We have now the AI function is something interesting. At first this function blocks if the tank is dead, so there are no zombie tanks. Also if we are blocking, so if there is something in the way, we try to turn right and left to escape the situation. We have the distance. In this distance we look for other tanks that are inside of this distance, so our sight range. And for this sight range we select a target, and if we see a target, then we try to move out to shoot. So we have these 3 lines that give a score for shooting, for turning left or turning right, and this basically this score is the distance from the target. So if it's better to turn, if the target is left from our turret, we have to turn left. If it's right from our turret, we have to turn right, and if it's in front of our turret, we want to shoot. And this is then evaluated, and the action is the performed action is stored into the tank class. Yes, if we did not find any tank to attack, we are looking for other tanks on the whole map, and if we found such a tank, we are now trying to control the tracks. So we have also a score for turning forward, for driving forward, for turning left, or for turning right. And then we evaluate which is the most effective way to get to our target, and then we set this action to it. Now the shot class is very simple: X, Y, angle, and the tank who started this bullet. We have a tick function which adds something to the position based on the angle and the shot speed and our frame factor. So Pfahrer has a variable frame rate, and we look if we hit something, and if we hit something we return this tank. In the draw function we draw the sprite at first of the shadow and then of the bullet. Okay, this basically was it. Thank you.